Welcome back, my dear friends. We are studying some concepts of psychrometry, and we would be in this video talk about the bypass factor concept, and we will be solving the numerical which involves a bypass factor for a special problem of cooling and dehumidification. We know that cooling and dehumidification problems are the numericals which we encounter when the process is when the climate is hot and humid. So we will take one example where some imaginary place is there, and in that imaginary place the climate is hot and humid, and let us say that this is some 37 degrees centigrade dry bulb and 19 degrees centigrade wet bulb. So this hot and humid here we are interested in conditioning. So what we do is that we purchase a air conditioning coil from the market. Okay, and let us say its capacity is some 4 TR, and this is this hot and humid air is allowed to pass over this cooling coil so that it becomes conditioned, means it becomes cool and its temperature reduces, its humidity also reduces. So we are interested in knowing, right, that what is the temperature of the conditioned air after passing over the coil of capacity for 40R. We are also interested in knowing its wet bulb temperature. Okay, so let us call this as state 2, T2 dash and T2. Let us call this as state 1. We will also have another information that this coil is at a surface temperature of 5 degrees centigrade. Right. So how do you plot describe this process on the psychrometric chart? So let us say this is your psychrometric chart. We all know this is a psychrometric chart. This is the corresponding dry bulb temperature. This is the specific humidity, right? This is the saturation curve, and the surface temperature is known. It is 5 degrees centigrade. So this is your state yes, right? And your initial state is known. So this is your condition line. Okay, please consider that this case is on the saturation curve. So this process is your condition line. 1, 2, yes. Now we are interested in knowing where is the state 2. That is a problem. State 2 is to be determined. Now how do we determine the state 2? For that, what we do is that we make use of the concept of the energy balance of the coil. So you know the energy balance of the coil is capacity of the coil in terms of refrigeration is the mass flow rate into H1 minus H2, and this is your sum H2 which is unknown. Let us say that is your state 2 which is to be found out. Okay, and we also know, let us say that in the problem it is given that, one more information I had forgotten to tell you, that the flow rate is 40 meter cube per minute. This is also information which is available to this, 40 meter cube per minute, right? So now if you know this flow rate 40 meter cube per minute, then we can find from the psychrometric chart value of V1. So that value, whatever you get, that value is the specific volume. Okay, so in this case it comes to be some 0.874 meter cube per kg from the psychrometric chart, state 1. And you can also find the value of H1 from the psychrometric chart, which comes to be around some 54, and yes, its unit is kilojoules per kg. So you know the specific volume at state 1, you know the enthalpy at state 1, and you can easily find out what is the mass flow rate, which is the same as state 1 and state 2 by mass balance, which is equal to then 40, which is meter cube per minute, upon the specific volume, which is 0.874. So this is how you find the mass flow rate. And then I was talking about the energy balance of the coil. So this mass flow rate which you get over here, that is 40 upon 0.874, you divide it by 60, so that this mass flow rate would be in kgs per second. Okay, so this mass flow rate, and this is your 4 tons, so 4 into 3.517 kilojoules per second. This value you already seen from the psychrometric chart, which is 54. So substituting these values and the energy balance of the coil, you get H2 value, okay, by calculations. And that H2 value, once you get, is around some 36 or so. This one 30, 35, 36. Okay. After solving this, once you get this value H2, then what we can get is the state 2. So you get state 2, by finding H2, right? So once you get H2, you get state 2. Once you get state 2, you can find T2. So you can find this T2 from the psychrometric chart. Getting it? So how do you find T2? So once again I'll repeat, how do we find T2? So we find T2 by doing an energy balance, okay, of capacities m dot into H1 minus H2, find m dot, and hence find H2. Once you get H2, you have already drawn the condition line by joining the state S, which is 5 degrees centigrade on the saturation curve, with the state 1. So this is already drawn. Okay. Now, once you know the value of H2, then this value of H2, once you plot it over here, you get the location of state 2. And once you get the location of state 2, you can find T2. So this is how you obtain the leaving condition, coil exit condition, temperature T2. Now what next? So uh, once you get T2, again from the psychrometric chart, you can get T2 dash. So that was asked. Okay. So the exit conditions are now obtained. Exit conditions means what? Coil exit condition is this. You are knowing T1, you are knowing T1 dash, and now you have found T2 and T2 dash, right? So this is one part of the problem. The second part of the problem is getting the bypass factor. So bypass factor is what? So bypass factor, as we had said, is the bypassed, so the temperatures across the bypassed here upon the drop which we achieve without bypass. So the drop which we achieve without bypass, I'll just draw again the diagram so that you will understand what is bypass factor. So this was your 1, this is S, and this is 2. Okay, so the bypass factor is, if you look at the psychrometric chart, it is T2 minus Ts. Okay, so this is the temperature drop, T2 minus Ts, and in absence of bypass, the drop would have been T1 minus Ts, right? So this is known as bypass factor. Now you already know what is Ts. This is the coil surface temperature of 5 degrees centigrade. This is also known, in our problem it is given to be some 31 degrees centigrade. This you have determined some value, whatever value it comes around 17 degrees centigrade or 16.7. So this is determined, and hence you will get the bypass factor. So it comes to around 0.4. So this you try to understand that bypass factor is easily determined if your capacity of the coil is known. I'll just once again repeat what we had done as a methodology, and then we'll stop this video. Okay, so what we had done was, what was given was, there was a cooling coil whose capacity was 4 TR. Your initial state was known, T1 was known, initial state was known, T1 and T1 dash, and you wanted to find T2. How did you find to that? You first did an energy balance where 4 TR you equated with m dot into delta H, and then you found H2. Once you got H2 from the psychrometric chart, you got T2. And once you got T2, then by knowing bypass factor, you got the value of bypass factor as this expression. Okay. So this is about how to solve the numericals for a cooling and dehumidification process when the bypass factor is to be determined, when the exit conditions will be determined. Given is the capacity of the coil and given is the inlet condition. Thank you very much.